Hello and welcome to another SME Media webinar. I'm Amy Bryson, contributing lead editor for Smart Manufacturing Magazine. Today we will explore 3D printing as a game changer for the industry, moving from prototype to full production. And this presentation is sponsored by Humtown, a third-generation family-owned business based in Ohio that, after 60 years, is one of the world's leading 3D sand printing service providers for the metal casting industry. And our presenter is Brandon Lamoncha, and he is Director of Additive Manufacturing at Humtown. And before I turn things over to Brandon, I just want to go over a few quick housekeeping items for our attendees. If you look at the right side of your screen, you'll find a question and answer box. And if at any time during the presentation you'd like to ask a question, just pop that question in the Q&A box and we'll answer it at the end of the presentation. If we don't get to all of the questions before the webinar wraps up, any unanswered questions will be responded to via email. And if you experience any technical issues like a loss of sound, please also use that Q&A box to alert us, and we will respond individually with a suggested fix. If you can't regain access to the live webinar or have to jump off early, this presentation will also be available in its recorded format after about 4 p.m. Eastern today. You can watch the webinar as many times as you like. All you have to do is log in using the credentials you used to join us today. We also encourage you to share those credentials with any colleagues who might also benefit from this topic. Now it's my pleasure to turn things over to our presenter. Welcome, Brandon, and thank you for joining us today.
Hi, thank you so much. Great to be here. Appreciate the introduction and appreciate the opportunity to come to all of you today on a busy Tuesday. I know everybody has, limited time, so I appreciate you joining and taking the time to learn a little bit about Humtown and what we do and how we're transforming the metal casting industry as a technology integrator with 3D printed sand cores and molds. A little bit of my background. I have a 3D background in CAD/CAM. I was made tooling with a pattern maker background for years. I ran our CNC department for about 10 years right out of high school. Then I got into some program management for high programs, and then got into sales and handled some of our strategic key accounts. And now I'm currently the VP and the Director of Additive Manufacturing at Humtown. Humtown, we started out, or a third generation family-owned business, as she mentioned. Started out in this building right down here that you see in the bottom of your screen. My grandfather was a pattern maker, and he started the company as a pattern shop, making patterns and core boxes for local foundries. And then we grew into a sand core and mold manufacturing company. We made sand cores and molds for through the Midwest. We did that. We would ship within a 400 or 500 mile radius, and we have done that for over 40 years now and became one of the lead core manufacturers in the Midwest. So that was a video of making traditional sand cores using, leveraging tooling investments. And at the time, we didn't know exactly where we were going to be going. So we started out using Fortis 3D plastic printer for making tooling on some of our tools that had 4-axis and 5-axis loose pieces and more complicated geometries, we were using a 3D printer to make those instead of CNC cutting them. But what we quickly learned was that we were going to start seeing 3D sand printing become more and more prevalent in the industry. We're going to talk about that today. So as of right now, we're no longer making tooling at Humtown. We do, we outsource that to other shops. And now our primary focus is 3D sand printing for molds and cores for the foundry industry. We have 2 locations, as I showed you there. Our most recent acquisition of a building is for our 3D sand printers, and that's what we're going to talk about today. And like I said, we're a 3rd generation pattern shop turned into a core shop, and we're one of the largest 3D sand printers in the world. I would be remiss if I didn't talk about the opportunity that we've had with America Makes. They really helped us jumpstart our getting our footing into additive manufacturing. America Makes was launched back in 2012, 2013 in Youngstown, Ohio, and we had seen this technology being provided at Rapid and some of the other events, but we didn't know how to engage. The printers were very expensive. There was only a few of them in the United States. So we were very fortunate. We came up with a couple project calls. The first one that we came up with was the acceleration of the adoption of additive manufacturing for the foundry industry. We had great project partners like OEMs like Caterpillar, universities such as Youngstown State, University of Northern Iowa, and even some of the machine manufacturers themselves. So we were very fortunate to have America Makes right in our backyard, and it really gave us a leg up on getting into this technology. Today, we're going to focus on binder jet. I'm sure a lot of you are very familiar with additive manufacturing and all the modalities and disciplines. Today, everything that we do at Humtown is the binder jet process. So we basically use like a silica sand or a ceramic media coated with an activator. It's laid out. The inkjet is being applied by the print head. It's a 2-part chemical reaction, and we're going to see that in this video that I'm going to show right now. This is one of our larger format S-Max 3D printers in action. Like I said, it lays down the sand that's pre-activated, and then the binder is deposited with the inkjet printhead that you see now. That 2-part chemical reaction takes place, and within basically an hour of the job box being completed, it will come out, and then we start using a vacuum, and we are able to vacuum the loose powder, and we're able to remove that, and we're able to take those cores and molds out and package them for shipment. When we started in this venture, we started, and as I mentioned, there was very few of these assets in the United States. Most of them, Ford Motor Company had 3 S15s. They were a captive shop doing development for the Ford Motor Company. X1 was the seller of the machines. They had a few machines that you were able to, as a print service manufacturer, so they would produce parts for you. But there were only a very small number of printers available for that. And then another pattern shop in Indiana, and then Magellan Aerospace was another captive opportunity, and NavC on the West Coast had one, which was also captive. So very, very few opportunities for companies like ours to engage with this technology, and that's why we were so fortunate to have America Makes. They partnered us up with that program. We got involved with the University of Northern Iowa, and I spent many miles driving back and forth from Ohio to Iowa to work with Jerry Thiel and the university. And we were able to learn about the printer. We were printing parts, and we were providing printed parts to the industry to start telling everyone about this technology, how to use it, when to use it, where to use it, why to use it. So we were very fortunate to have that America Makes introduction to you and I. Fast forward to 2022, and now there's over 100 of these large format 3D sand printers in the United States, in North America, some in Mexico. A lot of them are owned by OEMs, and then there's a few service providers like ourselves, like Humtown Products. But what we're starting to see is, more and more OEMs are starting to design castings that need to be produced using additive manufacturing. So what that's doing is it's, the metal casters, the foundries are starting to see, hey, we need to use this technology to provide castings of the future. We can get rid of backdraft and undercuts and draft. We don't need that anymore because we're in a toolingless environment. So it's been very, very good for the industry, for OEMs to see the opportunity for this technology. And we're very proud to be one of the leaders in that space. This was our first facility back in 2016. We got our first machine in North America, or at Hometown. We partnered with Youngstown State University to put this machine in. They didn't have the space for it, and they had a very large opportunity with America Makes. So we got together. We installed the machine, we operated it, we managed it, and we printed parts for the university and for projects for America Makes. It was very successful, and we were very honored to be a part of that team. And now we're able to start showing the industry and OEMs, what are some of the benefits. So, some of the main benefits that you can see on this graph is, in conventional manufacturing, we were up to 12. Now we're up to even 14 to 16 weeks to get pattern equipment and tooling to get a casting to a customer. With additive manufacturing, from a digital file, we're able to get castings, that have been, basically they're designed. We did the mold simulation modeling, for flow and for filling, to look for porosity. We 3D print the mold, we pour the mold, we do a color map overlay scan of the part, and we get that casting to the OEM or to the machine shop in about 3 weeks. It's been faster in cases. We've had some emergency situations come up where we were able to get castings, very, very rapidly to the customer. So that's one of the main benefits. And then one of the other benefits that we've been really seeing is part consolidation. Anytime you have, any kind of valve body or hydraulic valve body, you have stacking tolerance. On the left, it took 8 cores to be produced from conventional tooling. And every time you make one of those cores, you have the chance for it to break. You have to take it to an assembly area where you're using jigs, fixtures, glue. All of those are failure modes. So by having the produced core on the right as a 3D printed part, we're able to, greatly minimize scrap. Yes, 3D printing costs a little bit more, but the value is incredible. This was an air brake valve on a train, and how important is that for a safety critical part? To have no glue, no stacking tolerance. We were able to cast features in here that had to be machined due to very small passageways. And they ended up having to drill that using the 8 cores on the left versus the 3D printed core. A lot of people think that that it is only for prototyping. That this technology is, and it is a great tool for prototyping. But we're starting to see applications now going into full production, and we're going to talk a little bit about that. But I always like to have a few slides showing people, size. This was a 6,000 pound casting that we did at Caterpillar, Mapleton, an iron casting. They saved. This was a great example of where they didn't have to purchase tooling. And sometimes, production is only a few pieces. On some of this legacy equipment, you have cats and dogs, where they lost the tooling or they just need one replacement part. So sometimes it is still used for new product or prototyping or legacy parts. So we don't want to discredit the technology from that. Another way is we're seeing some of these really complex tools that need to be eliminated, and we've literally thrown them away because 3D printing the core gets basically a uniformly dense product, whereas before, when we had to try to blow these cores, we weren't able to get a uniformly dense part because you're trying to take sand with a binder in it and put air pressure to that and fluidize it and fill a cavity. It was very, very difficult. So by using 3D printing, this was a legacy aircraft product that we've now in production, low volume production. But we literally threw the tool away, and we now produce the parts using additive manufacturing. We do a lot of hybrid projects, and this is where we're starting to see, we have some turbo housings that we're doing now that are, 70, 80,000 EAU. So, some of these cores used to be made in halves and glued together to get the geometry for this turbo, for the volute. And now with 3D printing, we're able to print that all as one piece. We don't have to have any draft. We're not worried about undercuts and backdraft areas, so we can achieve the performance that was intended without having to sacrifice the tooling design. And what we do is we don't have to 3D print the entire mold and core package. We're literally just printing the core with the complex internal shape, and the outer shape, that's been, that is very simple and, not a very complex geometry. We're still making a tool for that. So this, when we talk to OEMs and to foundries, we find this is the lowest hanging fruit. When you have a complex internal passageway that needs the core, we're using 3D printing, and then we're still making a tool and using their molding line. So whether they have a Hunter, a Cinto, a DISA, a high production foundry that's making 20, 30, 50, 100,000 pieces a year can still use 3D printing in production, but it's not a full 3D printed mold and core package. We're looking at these hybrid projects. So when you're talking to your foundries and you're looking at using additive manufacturing, be sure to talk to them about a hybrid approach, only using the complex internal cores, because that also keeps the costs down. A large mold like this could be, hundreds or thousands of dollars, but a core package, if it fits in the size of your hand, very complex, that would have been multiple assembled cores. Now we're able to do that in a very cost-effective manner. And another hybrid project is, all of these cores were made off of tooling. They were, and what we did was we made a custom water jacket core. And now at our facility in Columbiana, we will no longer 3D or conventionally blow these water jacket cores because we had such a high fallout rate. We would blow 100 cores and we would have a 50% fallout rate. And then by the time they shipped to the customer, another 10 or 20% would be broken. So we were not yielding many parts. So we now, make all the other cores for this, V8 engine block conventionally off of tooling, but the very complex core of the water jacket with the very thin, narrow passageways that were, hard to get uniformly dense when we blew the core, we're now using a hybrid approach, and we're using 3D printing for that application. And what we're seeing moving forward is we're starting to see complex cores that are only able to be printed. We have some customers where, they were getting port-to-port variation. We've ran projects where, the intake and exhaust ports were moving, in casting. So they were actually designing the ports where they were in a fixed location, and that way we were getting uniform wall thickness, around the port, between the port and the water jacket. And, this was, and we're also able to do some venting and some other really unique things using 3D printing to get, to really push the boundaries of what, sand casting can do, in performance applications. So this is another great opportunity when you're talking to your casting providers, if you're looking for a high complex design, and you really need to, have very tight tolerances, 3D printing, a stable core package where the core is all one piece, monolithic core can really be the solution. So where are we at today in the sand cast metal or, part of additive manufacturing? We're really into the late majority. Investment casting and wax tools have always been a little bit ahead of, of the sand cast guys. But we really are over, there is no more early adopters or early majority. We're now into the late majority. And we've seen that with, with that graph I shown earlier about how many printers, with over 100 printers in North America, we're really starting to see, widespread adoption, using the applications, as I mentioned, where they make sense, highly complex, consolidated cores, hybrid applications, and now that we've been able to educate the industry, we're starting to really start to see, widespread adoption of additive. We're starting to see this, in OEM magazine. This is a Casting Source magazine. This is the Mercury Verado 600 horsepower. This casting for the lower power steering housing, is a 3D printed core. We produce 4,000 to 5,000 of these a year. And that was how this foundry was able to achieve, this casting. So, we're, like I mentioned, they're not using a full 3D printed core package. We did to prototype it, but in production, they're using, a semi-permanent mold process where they have a die, they're setting the core in place, pouring the aluminum, and they're yielding castings in production using 3D printed cores for that application. So, we're, as I mentioned, it's not just prototyping. We're starting to see full serial production of 3D printed cores, to produce castings. And, when I started in this industry, and versus when my grandfather started in this industry, we have seen a steady decline in foundries in North America, which is very sad, and it's been very difficult for OEMs because a lot of OEMs are really struggling to get castings, and we've seen that in my years at Hometown, but in the AFS, the American Foundry Society, we've seen a dramatic drop, but it is leveling off, and we are starting to see the value of those foundry shipments going up. We're starting to see foundries, come into a niche of what the product that they make, they're becoming very good at that product, and we are starting to see that. So there is hope. There is, a lot of foundries are becoming more and more technologically advanced, adding simulation software, adding having internal design teams that are providing molds and core packages to Hometown that are ready to print. That means they've taken into account all their clearances, any clearance for wash or chills or anything. They're designing this in-house rather than having it outsourced to a pattern shop or even to us. We're starting to see more and more foundries hire engineers and have them on staff to make these core packages and these mold packages for these complex castings. So we're very excited, to see that. So, a little bit more about Hometown. Here's another video of as we've grown. In 2019, we got a new facility and we put in our second 3D sand printer. So we moved into this facility. We leased this space because as we were growing, we didn't know how much space we were going to need. But this is what a 3D sand printing facility looked like in 2019 at Hometown. Lots of room, lots of area for the cores as they were being cleaned, packaged, raw material storage. In just 2 or 3 short years, that facility, we'd pretty much already outgrown it. At this time that this video was shot in 2022, I think we had over 10 machines in that area. So we saw rapid explosive growth of this technology in the industry, and we've continued to see this growth. Not only us, but we've also seen more competition, enter the marketplace, which is good because, foundries and OEMs are starting to believe more and more in this technology as there is a robust supply chain. If Hometown was the only supplier and there was no other ways for foundries to get cores and molds, they would be a little more apprehensive. But now that there is a robust supply chain, there's multiple printers in the market, and there's multiple print service providers as well as foundries putting in their own printers, the OEMs are starting to have more of a demand pull rather than me having to be a supplier push into the industry. So we're very excited about that. In 2022, it's been pretty much the same the last couple of years, but we were going through 4 rail cars of sand per month, which is 500 tons of sand. So we're not buying little containers of powder and or filament rolls. We're literally buying our material by the rail car. So it really speaks volumes to the amount of production that we're doing, in this technology. We've recently, just this past year, we moved into a facility that we purchased. So we're very excited about that. We can house up to about 15 machines. We have 12 in this building now. We realized that after this growth, we'll probably need to become a little bit more regional because we are shipping coast to coast. We ship to Mexico almost every week or every other week. Ship to Canada every week. So we've realized that our growth, this is about as large as we'll probably grow. 15 machines or so here in Northeast Ohio, and then we will need to set up operations in other parts of the country and the world. We have a partner in Europe we're working with right now. We're getting our first machine set up over there. They're already doing some printing for us in Europe, which is very exciting. For a small family-owned business, to see global expansion. and customers, around the globe is really, really exciting for us. And for the OEMs that we serve, we have hundreds of NDAs with, our leading, pretty much every OEM, in the country that uses sand castings. We have a direct relationship with at some level. And it's very exciting for me to be able to work with leaders, in all of those areas as we push, castings into the next level. So the future for Hometown, what are some things, moving forward? Before we moved out of the other facility, we had done a project into robotics. This is for robotic extraction with vision technology. So we're very excited to utilize, robotics for some of the jobs that, to be quite honest, that, that people don't want. We can get thousands of tiny sand cores into these 3D printers. So one of the things that we are looking at doing is, we had this cell in and run off, and now we're moving the equipment into our new facility. So it'll be up and running shortly. But, robotic, vacuuming and extraction, what does that look like for Hometown? And, so that, our people are able to be working on, the final packaging and the other aspects. So we're very excited to get this back up and running in our other facility, because we know that, as we grow into production, there's going to be more and more need for robotic extraction and handling of these parts. So this going with robot is grabbing one, taking it out.
Go, Sandy.
And then another part of this, is the qualification of parts and the inspection of parts. Now, we haven't purchased this system yet, but we are working with companies that are doing, basically, this is like a color map.
We should have a warning or something.
So what robots do you run with?
As I mentioned, we're starting to see more and more, aerospace and other, safety critical parts. So as we see that, we're going to be ready. We want to be ready at Hometown for that inspection. So we're looking into these technologies. I've also looked at CT scanning. We have some complex assemblies where it's very difficult to ensure that blind pockets. We can print stuff, but that doesn't mean that we can clean it. So we sometimes on these internal cavities, when we have to depowder them, we have some methods and some ways, but we also have to inspect, and make sure that we did get it clean. So I've actually flown parts out to California. We have some other CT companies in New York we've sent parts to, and we've actually, put the sand core into the CT and scanned it, and it does like a color map overlay of the internals, and to make sure that there's not any fugitive sand in there. So we haven't had any jobs that we've had to do that in production yet. We've bid several jobs and we've quoted that. So it really is, something that we're looking at, because we know that we have to produce a part, that's going to make a good casting for our foundry partner. And as I mentioned that, we do not cast metal at Hometown because we'd be competing with a lot of our customers. So one of the things that I always, am excited to see is, what does the foundry of the future look like? If you've been to Brembo and some of these, large brake rotor companies, you see them pumping out millions of brake rotors a week. And it's incredible. There's almost no way faster to make a near net metal shape than a casting. So I totally am a believer that, metal casting isn't going anywhere for a long time, if ever. So traditional patterns will always need to be there. I showed you some of the opportunities for a hybrid where, we're going to use a traditional pattern. We're going to have that in the foundry, but we're going to have a digital inventory of these complex internal cores where, it may have taken 8 or 10 core boxes and a crew of assembly people to put those together. But those are going to be introduced together at the foundry now to yield that casting. But I'm also, looking at the future and seeing that, there is a lot of great technology for direct metal printed parts. And I've been an advocate to foundries to look at that as an opportunity, not as a threat, and say, hey, you already have a lot of the metallurgists. You have a lot of the team members in your facility that understand metal better than anyone. So why don't we, look at that as an opportunity and look at direct metal printing, because you also have a lot of the inspection, the non-destructive testing, down a lot of the post-processing. Some foundries even have a machine shop, for checking the metallurgical, chemistry and for the parts. So I've been an advocate of seeing, out of that digital inventory, I think some foundries may actually incorporate direct metal printing. And, as a service provider for the metal casting industry, that's something that we've looked at. We haven't procured any direct metal machines yet, but we feel that we're positioned because of, our expertise in binder jetting and in additive manufacturing, that someday we will also be a print service provider of direct metal parts once that technology becomes a little more mature. So very exciting times. I hope, I've brought up some things in this webinar to, have you seen that 3D printing in the foundry industry now is not just for prototyping or for legacy parts, but there really is production intent and design happening. It's not something that could happen, it is happening. And I hope that it's going to inspire some conversations between OEMs and, people that are buying the castings as well as designing castings, opening that conversation with your foundries. And as needed, Hometown, we offer, we will come in and, be that technology integrator. We'll, be a part of that conversation with your foundry and help them get up to speed if they're not using, the 3D printing for the cores and the molds, but the OEM or the, casting buyer has that need. So with that, I am going to wrap up my presentation point, and I want to leave a lot of time for questions and answers, because I've seen a few pop in. I've been hard to read while presenting, but want to have a lot of time for discussion and to get through questions. And like I said, thank you again so much for your time today. Take my email down. Feel free to shoot me questions. It's been great to be here today and give a little bit of insight on additive manufacturing and how it's not just for prototyping anymore.
Excellent. Well, thank you, Brandon, for that great presentation. And for our attendees who are hanging on with us, make sure that don't wait to engage Brandon. He's right in front of you. So if you're holding on to a question and you want to ask it, make sure to pop it into that Q&A, and hopefully we'll have time to get that answered for you today. All right, Brandon, let's start out. We've gotten a handful of questions come in. So how do you determine the price point where it's more economical to print versus using hard tooling?
Yeah, that's a great question. That's one we get asked, pretty much every project. We have to look at it and just say, is it complex? Like for the brake rotor example, if you're going to be making $1 million of something and it's a fairly simple part, and that the design is pretty close, a lot of times tooling does make sense. What we're seeing is, when we sit down and we look, at these cores and we look at the design, if there's a lot of assembly, it's going to take a lot of man hour and, person time to put those together with glue and jigs and fixtures, and there's a high rate of failure. Almost every time, it makes sense to use 3D printing. But it is a case by case. There's no magic calculator, unfortunately, that we can throw a model in and say, oh, this one makes sense to do this. But you kind of look at it from a complexity standpoint and say, if it's complex, if there's a lot of assembly, that's when we're going to use additive manufacturing. And then the other time is, even if you think you're going to go into production using tooling, a lot of times, speed to market is everything. So what's it cost and what's it worth? If you can prototype and make a mold and core 3D printed in a few weeks, fail fast and pivot, right? So if you can design it, machine it, find out it didn't work, make an iteration, print another one, now you're ahead of the game. Whereas if you're still waiting 12 weeks for tooling and then fail. So I always, look at those two, and say, it's almost always worth prototyping it in additive and then looking at the hybrid if it's complex.
Great. A couple other questions. So do standard sand casting tolerances apply? And then adding on to that are there size limitations? So those are from the same person.
You saw that large casting we did with Caterpillar. They did a color map overlay of the casting. Thing was, 8 or 9 feet in diameter. It was huge, and they were plus or minus 60,000. So it was tighter than they expected even from tooling for that large of a casting. So I would say, and we've had some smaller castings that actually, the accuracy, it's nearing investment casting, so we can get a much more accurate. The only downside is 3D sand printing. We don't get the surface finish, so it's not. I mean, with wash and with very fine aggregate, we can get a better surface finish, but it's still going to be a sand cast finish. So
Okay.
I would say accuracy is typically a little bit better because with this technology. And size limitations, there really is none. We can stack and design these molds, and we pin them, and like almost like Legos, we can make a mold that's 100 feet long if we need to. So
Wow.
in each job box, yes, there's a limitation. It's like 1.8 meters by a meter by 700 millimeters. But as far as putting them together to make a casting, there's really no limitation.
Okay, great. You touched on this a little bit toward the end of the presentation, but can you give a little bit more insight into how easy or hard is it to depowder a sand mold with internal cavities?
It can get pretty complicated. We've come up with a few techniques that work pretty well. But it really is. Sometimes we'll even have like a clean out pocket where, if there's like a corporate area, maybe we'll have basically a plug that we'll print that separate. We'll go in, we'll clean it out with low pressure air, vacuum, and then we'll plug that if we have to. And like I said, there are applications where, for highly safety critical parts where we've had to quote, basically putting it in CT and actually scanning each part to ensure that it was clean. So it can get complex. Like I said, I've had people send me complete molds, no coat, no drag, no core. They literally wanted me to print it, all as one piece, which we can print it, but we can't get all that fugitive sand that, because of the binder jetting process, it's laying down powder everywhere. It's just, it's selectively, putting the ink to cure it. So we can print it, we just can't clean it. So there are applications where you can print something that can't be cleaned.
Okay. And can the used sand be recycled?
Yes, we can take the used sand. So like, we don't actually do reclamation in-house because everything we print, we're shipping out to foundries. But all of our foundries, especially if they have thermal reclamation, they'll just reclaim that sand right back into their process. The sand that we depowder, we can reintroduce that back in up to about 30%. Which we can reuse just about all of it because of how much printing we're doing. So yes, we can take that reclaimed sand that hasn't been activated, basically, it was only, has the activator on it and it didn't have binder on it. And we can run that back through at about a 30%.
Great. And then I think we just talked a little bit about this, but approximately what's the largest and what's the smallest size that can be printed in sand?
Yeah, largest, like I said, those sizes, on our printer, now Voxeljet has a VX4000, I believe, and it's, like 4 meters. So, there are different printers, but you're basically limited by that, but that doesn't limit your casting size. And then the smallest, it's really, we can print features that can't be cast. So, we still have physics and we still have pressures, and, I can print a wafer that's basically, 3 or 4 grains of sand thick, maybe 1/8 of an inch, but the pressure of the metal coming into that mold is going to break that fin off. So we're not yet able to defy gravity, and we still have physics and we have the heat, and it's going to burn in and burn through. So a lot of your rules for design in that case are still going to remain the same for traditional sand casting, your features and sizes, but we can print literally, wafers down to, a few grains of sand thick. It's just getting that to cast is still impossible. Just like we can make tooling that you can make a wafer, but it's not castable.
Got it. Is there any difference in surface finish for a part casted with 100% 3D printed mold versus a standard mold?
Absolutely. I touched on that lightly. Accuracy is plus or minus about 12 to 15 thousandths, which is just a few grains of sand. We're very accurate, but we have uniform density, but it's not as dense as a blown core because it's not being blown under pressure or hand packed like in a mold where it would be being rammed up. So you don't get that resin wipe where the resin is actually being pushed through the sand out to the surface of the mold or the die. So we do have a little bit of sacrifice there. We are able to use some coatings, and we are able to print in finer aggregates. So we can print up to 120 GFN sand or ceramic, whereas when we blow cores, we typically blow cores around 55 or 60 GFN. But we're only tamping, we're laying that sand grain on top of each other, and just with a light tamp in the 3D printer, we don't have that pressure. So there is a give and a take there, and we are able to get some of the surface finish back with coatings, but it still is not as good as a traditional die. So that's a great question, and we have 3D printing companies that are working on that. Sometimes you also will see the stair stepping. They're working on that, with dithering and some other software ways to get rid of the stair stepping. But there is still some setbacks with 3D printing. It is not, by any means the panacea that's going to fix everything.
Okay, is there a lower limit to part size where sand casting produces sufficient accuracy to be worthwhile? Expect some extra processing for faces that need accuracy and smoothness. The example is, our parts under an inch cube, just not a good fit for this process.
Yeah, it is geometry dependent. So okay. We have some parts that are very small, but they're able to pick up a feature that, because of a loose piece or backdraft or an undercut. 3D printing, even though the surface finish may not be as good as a traditional core, you may be able to pick up a geometry that you can't make. So, like I said, there's no 100% on any given design, or you can't just throw it into a calculator and say yes or no. It's you have to work with us or with your foundry to find out those applications. But we do see we have some very small little pipe cores that we're able to print out of ceramic material that trying to make those by hand it's almost impossible. But is the surface finish of the pipe as good? No. But are we able to achieve a geometry that we can't achieve by hand? Yes. So there's always balance and trade-off.
Yeah.
I would say, for micro casting, sand casting is probably just not your best bet either way. You're probably looking more at like an investment cast, or, now even some direct metal printed parts. So, we just have to kind of look at it pragmatically. We have to sit down, look at the application. And after you've done one or two of the projects, then you kind of get a better feeling for it. But yeah, I would say it depends. It really does on what you're trying to go after, and can you sacrifice a little surface finish to get a geometry that you can't make? Now, if it's a very simple 1x1 cube, 100%, just make a tool and make it conventionally. If it has some shape or some complexity, look at additive.
Great. Someone wants to know, can you adjust the size of the sand to improve casting surface finish?
Absolutely. I mentioned that. We can print with up to 120 GFN sand, ceramic or silica, round grain, where, we don't do that often. Our standard grade is about an 80 GFN. And like I said, traditionally, cores are made of around a 55 or 60 GFN. So you can kind of see, where we're already using a finer grade to kind of compensate for not having that blow pressure, that packed molder core.
And when would you use microcasting?
Like I said, I think it just depends on the geometry. It's just very geometry dependent. So I think you're going to look at it when, you can sacrifice a little bit of surface finish, but you can achieve a geometry that you're not able to achieve, with a tool or a die easily.
Okay. And then what is the typical, I love that, I'll put typical in quotes, typical lead time for a project?
Yeah, no, I understand. If it's print ready geometry, we literally are printing on average less than 7 days. We typically run a 7 to 10 day backlog, but if it's ready to print, we're usually printing in less than 7 days. If it's a project that needs engineering, design, going back and forth, literally, I would say 3 weeks, like I had on that graph earlier, is pretty accurate, pretty typical. That's, a casting, either a 2D print or a casting CAD model that comes in. We have to work with the foundry. We have to develop the gating, the layout, the feeders, the feed path, the runners, the chills. Then from there, we pull the mold, the cope, the drag, the core, add core prints. That usually can go back, depending on how responsive everyone is. But I would say usually a typical project, that requires a lot of engineering, scanning, designing, about 3 weeks, from the initial PO and CAD to, a mold being shipped to the foundry, that they can pour and get a casting to the customer.
Great. And what is the biggest factor in cost savings of 3D versus conventional?
I'd say, the biggest thing is really driving out the labor with the assemblies. That's what we've seen. That a couple of those cores that were in the high production, 50, 60,000 EAU, those turbos, you have to think, they had to set up a core blower, blow 2 pieces of sand core, bring it back to a room where they have people, with glue and fixtures, and, they would prep, they would glue, they would put those together. That seam around, where it needed to be, they have to go in and they call it mudding and take like core mud or core paste and patch, that seam so that metal doesn't go in there and create flash. But now we 3D print it, and once we get robotics and some more robotic cleaning and remove some labor out of it, I'd say that's really our biggest cost savings, and where I really see additive taking over is on these complex cores that require a lot of assembly. And like I said, when you take the glue and some of the cause casting defects and scrap out of it completely, we've seen projects that have like I was saying earlier, 50-60% scrap rate because of complex areas to fill on a core blower, completely eliminated, and down to we're at 98% good parts from the 3D printer.
Wow.
So labor and scrap driving all of that out of the process is really big. With using additive manufacturing.
Excellent. And if there's one or two things that you'd want attendees to walk away from today's presentation and this discussion, what would that or those be?
I would say, really, if you haven't, done some casting projects with your foundries and your current supply chain, start the conversation. If ask them to take a look at your product and say, hey, have we used, we're buying sand castings from you. Have we used additive manufacturing with your firm? And if not, why? And really just start the conversation, because you may learn something. You may be buying castings from a foundry that's been making them from tooling for you for years, and they're just waiting for that question. What can we do? What can't? And so, foundries are a little overwhelmed right now. There's been a lot of reshoring stuff since COVID, and that we're losing a lot of the knowledge is being retired out of the industry. Mm-hmm. So, they may not be coming to you as an OEM or a design engineer with these opportunities. So you may need to come to a webinar like this, get a little bit of background. You may even want to contact me and just say, hey, I have this casting. I think we can use it with additive. What foundries, and we can just start having that conversation. I don't think anybody needs to get the credit card out and, and go buy a 3D printed mold or core tomorrow. If they haven't, I think it's really walk away with, go out and ask questions, learn about it, and understand how this technology could benefit you and be a tool in the toolbox for you getting your castings.
Well, that's sound advice. Well, Brandon Lamoncha, I want to thank you so much for taking the time to share what you know with us. And I also want to thank our attendees for your participation. We hope you found today's content valuable and that you'll join us again soon. Until then, remember that SME and SME Media are here to help you stay up to date on all things manufacturing. You can find links to podcasts, additional webinars, publications, and news by visiting us at advancedmanufacturing.org. Take care, everybody.